A sequence that occurs often is an arithmetic sequence. Here's an example. Suppose we start at 5, and I'm going to add 2, takes me to 7. I'll add 2, takes me to 9, add 2, to 11, add 2, 13, 15, and so on. So the way I've written this is I get from one term to the next by adding 2 to the current term. So that means that these terms here, if I take two consecutive terms, like the right minus the left, they differ by 2, right? 15 minus 13 is 2. 13 minus 11, 2. 11 minus 9, 2. So if I take any two consecutive terms, 15 minus 13, I get a 2. 13 minus 11, I get a 2. And then I come down here, 9 minus 7, I get a 2. Now there's a name for that common difference, right? This difference is common all the way through, right? That 2 is common all the way through. So we call it the common difference. So I'm going to rewrite this sequence in a slightly different way. I'll start with a 5, and then how do I get to the 7? Well, I take the 5 and I add 2. Now how do I get to the 9? Well, I take this 7, but I'm going to leave it like this, and I'm going to add 2. So it's going to look like this. 5 plus 2, and then I add 2. All right, so here's where I am. This is the first term here. This is the second term. This is the third term. Now how do I get to that fourth term? Well, the fourth term, I'm just going to look at the third term and add 2 to it. Right, so the third term is this one. 5 plus 2 plus 2. And then I'm going to add 2 to that. Let's do it one more time. I think we'll see the pattern here. So let's go out to the fifth term. So how do I get to fifth term? I'm going to take the fourth term and add 2 to it. So I'll have this and then a plus 2. So it's going to look like this. The fourth term, 5 plus 2 plus 2 plus 2, and then plus 2 again. And that's the fifth term. Now let's go down and look at what we did here. I'm going to start over here at the bottom left with 5. I start with 5, and that's where I start. I don't add anything to it. But then how do I get to the second term? Well, I had a 5, and then I added 2 one time, right? So I have one of those 2's. What about the third term? I have 5 plus, then I have 2 of those 2's. How do I get to the fourth term? Right now I'm at the fourth term. So what do I have? I start with a 5, and I add 3 of those 2's. 5 plus 3 of times those 2's. What about the fifth term? I started with a 5, and then I added 1, 2, 3, 4 of those 2's. We're starting to develop and maybe even see a pattern here. I'm going to come out here to the right and put a 6. This will be the sixth term. Can you guess what do you think it would be? So look at the pattern that we have. If I'm at the first term, I don't add any 2's. If I'm at the second term, I add 1, 2. The third term, I add 2 2's. The fourth term, 3 2's. The fifth term, only 4 2's. So what about the sixth term? The sixth term, I'm thinking it's going to be about a 5 plus, should be 5 2's. So it looks like we start with a 5, and then we add how many 2's? 1 less than the term number, right? The term number is 6, we added 5. The term number is 5, we added 4. Term number was 4, we added 3. So I'll do this down here at the bottom left. What do you think if we're out here, say, at the 10th term? At the 10th term, what do you think? Start with our 5, and then add how many 2's, right? How many 2's are we going to add? Well, if our pattern holds, the number that we add is always 1 less than the term number, right? 3, 2, 4, 3, 5, 4, 6, 5. This should be 9. So now in general, if we were here at the nth term, okay, at the nth term, okay, dot, 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 we go out to the nth term. So what are we going to have here? We'll have a 5 plus, now how many of those 2's? Well, the number of 2's is going to be 1 less than this. So if this is n, 1 less than that is n minus 1, because there's more than one term, I'll put it in parentheses. N minus 1 of those 2's. So based on this idea, let's write a formula for this arithmetic sequence. All right, so the arithmetic sequence might start like this: A1, A2, A3, A4, dot, 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 A sub n. Now this is going to be arithmetic. So this is the first term, the second term, the third term, and these each differ by some number. Let's call it D, right? That would be D. So right here, A2 minus A1 would be D for the common difference. I'll use a D for difference. And then what about here? What about these two here? What do you know about A3 minus A2? Well, that's going to be D. So now, using what we developed through this example here, let's write a formula for the nth term of any arithmetic sequence. So we could say A sub n, our nth term, is equal to, well, what did we do? Let's go down and look at our example. What do I write here? Look at our example. What did you first write? Well, that was the first term in the sequence, right? In our case, our example was a 5, but now in more general, it's just any first term. So we're going to write A sub 1. It's the first term in your sequence plus, and then let's just fill this in. What does ours look like? Okay, n minus 1, right? That's the term before the nth term. So this is going to be parentheses, n minus 1 times, all right, look at our example down here. What was that, 2? Well, the 2, that was the common difference. Now, in general, our common difference, we're just calling that D. So this is going to be D. There it is. Here's a formula that will give us the nth term of any arithmetic sequence. What do we have to know? You have to know the first term and the common difference and n, the term number that you're looking for. Let's just do an example here. Let's find the 11th term of our example sequence. All right, so here's our example sequence. Can we find the 11th term? All right, so first of all, why don't we get some space here? We don't need that stuff anymore. That was useful for developing our example. But now I want the 11th term. So the 11th term, that's n, right? So what I'm looking for is this. I'm looking for A sub 11 equals, now, what's the formula say? Take the first term. Well, the first term in our sequence is a 5. So we'll have 5 plus, now our formula says n minus 1, n is 11, right? N is the term number that you want. So 11 minus 1 times the common difference. And in our example, the common difference was 2. All right, so let's just compute. So what do we get here? We get 5 plus 10 times 2. That's 5 plus 20. So this should be 25, right? So we're saying that the 11th term in this example sequence is 25. Now, while we're here in this introduction, I'm going to write another formula. I won't develop this one. I'll just write it. But what if you have an arithmetic sequence and you want to add up the first n terms, like the first 5 or the first 20 or the first 100 terms? Here's a formula for this. I'm going to call it S sub n, S for sum, and this stands for the sum of the first n terms. I'm going to write it two ways. Here's one way. You can write it like this. Here's a common form of it. It's n over 2 times A sub 1, the first term, plus A sub n, the last term. Now, to use this formula, if you want to add up the first, say, 50 terms, you would have to know, all right, 50 for n. You'd have to know the first term and, what, A sub n, the 50th term. So you have to know both the first and the last term. Here's a quick example. You know, in our example problem that we just did, we had this. We had 5, 7, 9, 11, right? That was the first term. That was the second term. That was the third term. That was the fourth term. Now remember, we did dot, dot, dot. We went out and we found the 11th term to be 25. So let's add these up. Let's add up all of these 11 terms. So what we're looking for here is this. I want the sum of the first 11 terms. So in this case, n is 11, and I have a formula for this, right? Here's the formula. What do I need? I need n, which is 11. All right, so this is going to be, now don't let this fraction bother you here. It doesn't come out even, but it will in the end. Times what? Well, what do we have in here? You have the first term, which is a 5, and you're going to add to that the last term, right? The nth term, the 11th term, which in our case is 25. So it's going to be 5 plus 25. So we get 11 over 2 times 30. Now do it this way. 2 into 30 is 15. 15 times 11, right? So I'll do it up here. S sub 11 is now 11 times, what did I just say? 5, and 25 is 30. 2 divided by 30 is 15. So S sub 11 is 165. All right, so I got the sum of those first 11 terms is 165. Now I want to take this formula here and write it a slightly different way, because this formula here, I have to know, all right, how many terms do I want to add up, but I have to know the first term and the last term. What if I don't know the last term? Well, I can get another formula for this by using my other formula for a sub n. Right? We already know this. We know that a sub n is equal to a1, the first term, plus n minus 1 times the common difference. So if I put this, okay, if I put this down here for this, here's what we'll get. We will get S sub n is equal to n over 2 times a1 plus, all right, now what is a sub n? A sub n, I'm just putting in that formula that we developed just a few minutes ago. It's a1 plus n minus 1 d, which I can simplify a little bit here, right? This will be S sub n equals n over 2 times 2a sub 1 plus n minus 1 d. You can hear my cat agrees with this. So now we have two formulas. We have this one here, and in this one, what do you need? You need the first term and the last term. And we have this one over here, and in this one, you still need two things. You need just the first term. You don't need the last term, but you do need the common difference. So here's an example. If we use our example from back over here, right? Let's just use an example. Let's use this one, and we'll find S11. Use this formula here to find the sum of those first 11 terms. All right, so it's going to be, right, I'm using this one, so what do you get? 11 over 2 times 2 times a1. Now a1 is what? Well, that's the first term in the sequence, and the first term in the sequence is 5, so we'll use the 5, 2 times 5, plus, now, what is this? N minus 1, right here. N is the term number we're looking at, 11, right? We want the 11 terms. So it's going to be 11 minus 1 times the common difference, which is 2. So we are going to get S sub 11 is 11 over 2 times this quantity, 10 plus, now 11 minus 1 is a 10 times 2. Where are we here? 11 over 2 times, what is this? Let's just do it all at once. 10 times 2 is 20. 10 more is 30. Get it to right here, 30. Oh, actually, before we go any further, look where we are. You see this? Right here? Same as this. So we end up in the same place. The arithmetic looks different, but we end up in the same place. So what have we got? S sub 11 is 2 into 30 is 15. 15 times 11, 165. So we have two formulas for finding the sum. We have this one here. This one requires, how many terms do you want? It requires the first term and the last term in the sequence, whereas this one requires the first term and the common difference.